5.7 and 5.8 are the culmination of everything that we've been building up to. So this is the reason we were learning our log laws. This is the reason and how we're going to use them, because a lot of math is about solving equations. And now we're going to get equations where yesterday you saw x in the exponent in new forms when you worked in groups. We're going to be doing questions like that again. We're also going to get equations where x is inside of a logarithm. And your log laws and your definition of a logarithm are going to help you solve this. So anytime you're solving a question where x is in a logarithm, you can use your log laws to get that as a single log. So you see that you have a log plus a log. What's your log? Right? Adding two logs is the same as multiplying. So I could change this to log 2 of x squared equals 2. Then, the step that we always seem to forget, so I'm going to put a little red star beside this, and right beside here, we're going to use our definition to change things to exponential form. If you have log 2 of x squared equals 2, chances are you won't be able to solve that in your head. But if you change it to exponential form, in other words, the base is 2, the exponent is 2, and it equals x squared, now you're trying to solve x squared equals 4, and you can do that by square rooting, and you get x equals plus 2 and x equals minus 2. The final thing that you're going to need to do you're going to check your original equation, because you're not allowed to take the log of a negative. What's our original equation? Our original equation is up here, the very start. And all we're going to do is plug in a number and find out if you plug in 2, you have log 2 of 2 and log 2 of 2. Both of those are positive numbers inside your logarithm. That means that 2 works. But if you go to plug in negative 2, you will have a negative inside of a logarithm. And if you think of your graph of your logarithm, its domain is only when x is bigger than 0. This is the idea of solving a log equation. The key idea is you want to use the definition to change it to exponential form. But you can only use the definition if you have a single log. So the first step in solving a log equation will be, can I get a single logarithm? Because if I can get a single logarithm, then I can change it to exponential form. Once I have it in exponential form, it's usually recognizable as an equation I've solved before. Oh, I've solved an x squared equation before. It isn't hard to solve, but then once you've solved it, you do have to check your original equation, because you're not allowed to take the logarithm of a negative number. So let's go to example 1. We're solving this. It is a logarithm equation because there's an x inside the log. So we want to think about those key things. The key things are, we want to change it to exponential form. In order to do that, the first thing we need is a single logarithm. Do I have a single logarithm? No, I have two logarithms. So I use my log laws to combine them. In this case, we're adding, so adding is adding two logs with the same base is multiplying inside the logarithm. And now you have a single logarithm. Okay? We can change it to exponential form. The base is 3, the exponent is 4, and it will equal 9x squared. And at this point, you've solved x squared equations before. 3 to the 4 is 81. Divide both sides by 9. You would get 9 equals x squared. Square root both sides, and you'll get plus 3 and minus 3. The last thing you have to do is check if both of those work in the original equation. If I plug in 3, will I ever have a negative inside the logarithm? No. This one works. If I plug in negative 3, I get negative 27 in the first one. So I can cross that one out right away. Okay? Put a star beside this step, because going from this step to this step, for whatever reason, well, I have a couple of theories of why, but this is where your brain shuts off. Because it's a little bit different than most of the algebra you've done. Most of the algebra you do, you sort of see, oh, I need to add 3 to both sides, or you see what to do and it makes sense. This is, right, using a definition. We don't normally do that in a math solving question where we completely change what the format looks like. So when you go from this step to this step, right, there doesn't seem to be anything algebraic going on. It's different. And because it's different, students seem to forget that step. Different is weird. Sometimes when things are different, you remember really easily. Sometimes when things are different, you can't remember. It's weird. Like someone tells you their name and it's like, that's a different name. Sometimes you'll like remember it forever because it's different. And sometimes you'll be like, I have no idea what their name is. I just know it's different. That can happen. Okay? So you have to pay extra attention at this step. Because that's the step that's going to be hard for you in solving these log equations. When it says verify the solution, it's just a matter of plugging it back into the original equation to see if you take the log of positive numbers or negative numbers. And if they're positive, they're going to work, unless you made, obviously, another mistake along the way. But if you haven't made a mistake, that 3 is going to work. If you plug in the negative 3 and you get a negative inside the logarithm, it will not work. Okay, we can circle questions